I just started.
Okay, so welcome to Math Lab. We're
Welcome,
on the road
welcome.
right now. We're in South Carolina, bridge tournament. So we're going to work on some problems. Here we go.
Yeah, so this is the first one we got. So the first thing I see with this is that we can use the secret property of logarithms. That made me really excited when I first saw it because this is 2 squared down here. So then you can pull that 2 out to the front and put it in a denominator. So then you have log base 2 of log base 3. Then you can also actually bring the n to the front as well. So of n over 2 times log base 2 of 2, which is just 1. So that's a beautiful thing. That just goes away since you're multiplying by it.
Nice. I love that.
And that's all going to be equal to 2. So, I mean, there's multiple ways you could go from here. What I would do is I would use
Start the
take the
same.
outside log and put it as an exponent.
We're missing one. We're missing one parentheses there.
Are we?
Yeah, just
Is that
one.
all we're
Yeah.
missing? Okay.
But so far, that's all we're missing.
Okay. So then we got 2 squared equals log base 3 of n over 2. And then 2 squared is 4. I would do the exact same thing. So 3 to the fourth is n over 2. 3 to the fourth is 81. So then n is 162.
Well, that's cool.
That's
That's
a
actually
really big number. Does that make sense? You're doing 2 to the 162 to start out the problem.
well, but then you're taking the log base 4, the log base 3, and the log base 2, right?
Yeah, which I guess does bring it down a lot. So yeah, that
Put
was
it
a
in your
good problem.
calculator. Put it in
What?
your calculator.
Put it in
Put
the
it in your
calculator?
calculator. Yeah.
So we got log. Oh my gosh, that's not what I wanted to do. Log base 2 of. Can Desmos handle this big of number? I'm not sure.
Oh no.
Because it might try to calculate 2 to the 62. And then it's going to have some issues. Log of 4 2 to the 162. Boom.
Equals 2.
Equals 2. No problems.
No problems at all. That's
Nice.
pretty okay.
All
Good
right.
one.
Next one. This one's pretty lame, to be honest.
Yeah, this one is super well, not lame, but I mean, if you know Pascal's triangle, it's a nothing thing.
Yeah, so what is Pascal's triangle? Would you? I would have to write it out. I would write it out and know that that's the good one because that's the one that has the fours in it.
Yeah.
So then you just got to worry about the exponent or about the coefficients and stuff.
Yep.
So you got the first thing to the fourth, so definitely x to the fourth, but then also 1 over 2 to the fourth, so over 16. And then I don't know, should I write it all out or try to do stuff in my head?
I would do stuff in your head. But so it's always gonna be plus minus, right?
Yeah, that's kind of the main thing I was thinking about because it's going to alternate because now we're going to have like the
Definitely
3 to
that's
the first.
right.
So we're going to have the x cubed and then the
Hmm.
1 half cubed, so
Yeah.
over 8, and
Yeah.
then the 3 to the first.
Yep.
And
Right.
then the next one will be plus because it'll be negative 3 squared. So we can even write that first, so that's going to be 9. Except for, hold on, we're totally screwing it up, right? Or I'm totally screwing it up. I'm forgetting the Pascal's triangle part.
Yeah, we need to add our coefficients, right?
So that one needs to be multiplied by 4.
Well, I would just write 14641. Like I would just write that at the very beginning before I do anything else.
Yeah, that's smart. But then you might run out of space.
Um, you gotta
But
just
yeah, that is smart. So then we got the 6. I'll go ahead and do that for you. 4, 1.
yeah.
So then 6, and then times 3 squared, times 1 half over 4, 1 half squared, and then x squared.
Okay.
And then minus the 4, and then 3 cubed times 27, and then 1 half x just to the first, so over 2 times x to the first, and then plus 1 times 3 to the fourth, which is 81.
Yeah.
And then you just got to simplify the little bits that you can. So that cancels, leaves a 2. That cancels 3, 2. This cancels. So we got x to the fourth over 16 minus 3x cubed over 2 plus 3x squared over 2. Is that right?
Sure. No. 3 times 9, right?
Oh, yeah. 3 times 9, 27.
Okay.
Where are you going?
You go down.
And 54x plus 81.
You got the room key?
No, I don't have any room
Hey,
key.
gotta give it to you.
I don't know where it is.
Very nice, very nice.
Hey, where
Very nice one.
There it is. You want me to take it? I'll take it.
Yeah, you better take it.
Okay. Your people are down there.
All right, I'll be there shortly.
All right, so what is going on here? This is the one you were asking about. With that A naught.
A prime means what?
A prime means not A. So everything that's not in A. So we could
That's
write
you.
A prime is C IJK.
That's what I said.
Okay, yeah. And then what is this? It's not union, it's intersection.
No,
So
you're
it's-
missing one. You're missing one.
I'm missing one.
No.
H. I'm missing H.
Okay.
And then that's an intersection. So we're asking what is the intersection between not A and B?
Okay.
So which one's in both of them? H, I, and J. So this right here is H, I, and J. And then what is not B? Not B is what's that? A. Oh, there's not A. I forget. What's not in B? C, D,
C.
E, and K.
Okay.
Is that this one?
No. No. You're good because you have
Oh,
five
yeah.
in
There's 5 in there. Yeah. Okay. So that's
your
B.
highlighter's a little. Your highlighter's a little pink.
It's a little dark.
Yeah, so it's hard to see sometimes. But okay, you're good. All right.
So then we got A. We want intersection between A and B not. So that looks like it's going to be D, E, and that's it. And so now they want us
That's
to do the union of that, which just means put all of those together. So it should be E, D, I, or I should say H, I.
Why did you go ED? Don't you think you should write DE?
Oh, D comes before E?
Yeah.
Oh, okay. Yeah. Well, that's why I changed the H and the I, but I didn't realize that D came before E.
That's why I'm asking.
Okay. Does I come before J?
Yeah.
Yeah, it does. Beautiful. That's why we're math people, not letter people. All right, so I already did this one, so that means you've got to do this one. I can write down what you say.
Oh my God. Okay. Wow. All right. Well, a dog and a fish. So we need a three-way table kind of thing.
Mm-hmm. Or I would go to a Venn diagram for this instead of trying to do a 3-way table. Although I was thinking earlier you could try to do a 3-way table, and the easiest way to do that is probably 3 2-way tables because that's making like a 3-dimensional table.
All right. Let me see.
It's a good one. I enjoyed this one.
Yeah, it's kind of fun. All right.
The worst part was that I got it wrong. I was so proud of myself that like I sent back an answer 5 minutes after Mr. Miller sent us this problem. But then I got it wrong because I did a simple subtraction problem wrong. And I did everything else right. So tell me what you're doing. You're just writing stuff down now?
A three-way Venn diagram. I got 3 circles: dog, cat, and fish.
All right, so tell me what's put where.
91 on top of the dog, 70 on top of the cat.
What do you mean on top of the dog? Like outside of the circle?
Just right there somewhere real close. 91. I just put it right on this on the circle. Yeah. And then I put 70 there on the cat. Put 70 on the cat.
Mm-hmm.
31. So I put 31 there in that middle.
Right here.
I put 31 right there.
Is that correct?
I mean, that's 31 people owning a dog and a cat.
It's true.
But there's 7 in that little thing. Okay, so let's do the 7 in the very, very middle.
Okay.
Yeah, so that means that's 31 minus 7. That's
Mhm.
31 on the outside. See, we shouldn't have put it on the inside yet. So 31 minus 7 is what?
24.
4. So 24 go there.
That's definitely
10
one of the tricky parts of this problem.
10 on a dog and a fish. So 3's got to go on the outside there.
Mm-hmm.
And then what happens here with the other cats? 31, 10 on a dog and a fish, 7 on a dog. There's none that own. 91 students do not own anything.
Yeah.
What does that have to do with anything?
91 students don't own anything. There's 240 total students. 91 of them have no pets.
Hang on a second.
So that's like your number on the outside.
Oh,
I always say that.
240 total. Hello? I will. I'll be down in shortly. And yeah, I am bringing it down. Tell him to get the thing ready. I'm bringing it down. Okay. All right. Goodbye. Oh my God. They're after me. Okay.
I mean, honestly, it probably makes it more entertaining when you answer a phone call in the middle of another problem.
Yeah, I know. Seriously. Okay. So now we got to draw the big square around it to put the 240. But I don't see how that fucking matters.
Well, we know there's 91 on the outside, right?
Yeah, but so what?
Okay.
Oh, do we need
Maybe
to
it
know
doesn't
that?
matter. I didn't say it matters. It's just
All
a
right,
fact.
put the 91 on the outside. Put the
I got
91.
it. I got it on the outside.
It's too close to the circles for me. It feels too close.
Well, that's because you're putting these weird numbers out here. There's, like
Okay,
those
this
numbers
should
don't
be really
belong.
close to the circles.
Those numbers don't even belong there.
Yeah, they do. Oh, please put it there. All right, so now 91 minus all that is that.
Yeah, so 3 7 is 10, so 34, so 91 minus 34. 57.
Okay. So 57's there. And then 70 minus 31. What is 39? In the cat bucket? Am I missing something?
Here?
Yeah.
What about here?
Well, there's nobody that just owns a cat and a fish.
How do you know that?
It doesn't say it.
Yeah, that doesn't mean it doesn't exist. Doesn't say that there's 57 people that only own a dog.
All right, so maybe we should figure out the other piece first then. If there's 91.
Also, we want to know how many people own only a fish. That's what it's asking for.
Right, so we want only a fish, right. But I think in order to do only a fish, we got to do 240 minus 91 to know all the students that own everything. We do need that 240 and that 91. So 240 minus 91 is all of that on the inside.
Mm-hmm. So that's 149.
149. And then I think we got 39 over there on the inside there. I don't know why you wouldn't have 39. And then it's just.
You just don't know that. You know, like this.
Yeah. Okay, so if we know that's 39, and we know that we can do 39 No, we can't do that. We know that's 39, and we know the whole thing is 149, right?
All these things added together is 149. Yeah.
So can't we just do 149 minus 39 plus 24 plus 7 plus 3 plus 57?
Mm-hmm.
It doesn't matter whether you know that there's a person who owns a cat and a fish, because you only care about knowing the whole fish. So you could have put 39 in that top bucket there.
So yeah, you could have gotten like 39 and 0, but it wouldn't have been correct. It would have got you the right answer, but
It's correct. So the adding all the things together, it's the same exact thing, because 39 plus 0 is 39.
yeah, but you don't know this. Like you don't know that this is true.
But you do know it for with respect to when the question is how many people have only a fish. You don't really care if it's 39 people who have a cat, and of those 0 have a cat and a fish, or 39 people who have a cat and all 39 of them have a fish.
Yeah. No, you're not wrong. You're definitely not wrong. You don't really care in this case, which is kind of what makes this problem cool, I think.
Yeah, no, it's very cool.
Because I did like an X, Y, and Z thing, and then I was like, yeah, Y plus Z is 39,
Right,
and then
so
I
what
know
do
that
you
like
care?
X plus Y plus Z is like whatever it is, and then you
Right.
do a little substitution.
Right. Well, you don't need to substitute. You just know that you take 149 and you take away all that other shit.
Well, that is substitution.
Okay, fine.
I mean, just multiple steps of it.
All right, that was good. What's the next one?
So this is actually the last one,
Okay, good.
and yeah, it's interesting. I mean, it's kind of interesting because like, do the tangents just cancel out?
Well, yeah, except that the tangent of 7 pi over 6 is what? Basically, what do we have to do to 7 pi over 6? What do we have to change 7 pi over 6 to?
Well, right. So that's what I mean. They don't just cancel out. You have to move it to the
It's got to be
right
pi over
quadrant.
6. Right, it's got to be pi over 6, right? It's got to be in the first quadrant. It can't be in the third.
Because what does inverse tangent always output? 1 and 4?
In 1 or 4, right. So that means that now the tan negative 1,
Students.
so it's
Isn't it quadrant 4?
1
No.
No, 7 pi over 6 is in quadrant
Because that's
3.
in
So
quadrant
it goes
3,
to quadrant
where
one.
all students take, so it's positive, so then it goes in the positive first quadrant. Yeah.
The tan of
Okay.
7 pi over 6 is
So all that's pi over 6?
yeah.
And then
Yes.
right?
Right. And then the cosine of pi over 6.
Yeah, I would just do that. That's root 3 over 2.
Right.
And then the inverse
Cosine
sine
of root 2
is pi over
is
3, right?
pi over 3. Right. Is that the right answer?
I mean, it's got to be, right? Yeah.
Yeah, I think it's the right answer.
I mean, do we need to type it into Desmos?
No, I love that. Anyways, it's fun.
I mean, there's not really a graph to look at or anything. But yeah, I always like to do a whole bunch of like, when I didn't even know what sine and cosine were yet, I would always do a whole bunch of sine and cosines on my calculator and just see how long it took for it to actually calculate it.
And
And I mean, it was just like one of those scientific calculators. I feel like when you did it on, like, if you did that on Inspire, it would just do it instantly. But you can get those scientific calculators to like take quite a while to actually calculate it. Boom. That's not right. Wait, what did we say? We said pi over 3 was the answer. Boom. That's right. Yeah.
all you have to do is change 7 pi over 6 to pi over 6, because you know you can't take the arctan of 7 pi over 6. That's it.
I mean, yeah, for sure. For sure. And then you could have done the little thing with when you have the inverse, when you have sine inverse of cosine of pi over 6, you could have like thought about the triangle and been like, couldn't you? Like, here's the pi over 6.
Of course. Although that's hard to wrap my head around, so I kind of almost would rather.
Yeah, no, me too. Especially, but if it was a bad angle, then it's like we'd have to do something like that. But maybe that's not right, because normally the inverse is the one on the inside. So maybe that's not how you do that. You could use the 90 minus thing, I guess. Or no, I don't know. I'm having a hard time seeing how that would work.
The arc sine of the cosine, right? So the cosine is adjacent over hypotenuse.
So then you're saying, you would say this is 1. You would say this side right here is the cosine of pi over 6.
Okay.
and then you're trying to do the inverse sine of this. So you'd say what angle has that as its sine? Pi over 3.
Yeah.
That's pretty convoluted.
That is convoluted, honestly. That's really convoluted. I'm
Yeah.
not kidding. I can't do that. I have to just do it.
Yeah, it makes more sense when it's the other way. That's how it normally is, when it's a cosine of the inverse sine. That's like what we're used to. And that's like the whole debate we had with Sean, and I would just like draw the triangle and stuff. And
I don't remember this debate that much, but okay.
I remember it a lot. I remember it vividly.
Sean. I love Sean. All right. Well, listen.
That's not a bad MATLAB. I mean, that's not a bad MATLAB video, I don't think.
Well, let's
I mean, it's a 20-minute recording. That's a pretty normal time for a video.
Okay, so maybe you could say, here's some mu alpha theta. We decided to do a few mu alpha theta things, put a little title, a little thing, and just send it out. See what happens.
Yeah, I'll do that.
And then we can always try to work with them more later and repost if we don't like. But I mean, you might as well be posting.
Yeah. Well, we don't need to repost. Just keep posting and just post more and more. Yeah.
Post away, post away.
Just keep posting.